Yes, Mustafa.
We are hearing
أوكي.
you.
في البداية أحب أرحب بالجميع باللغة العربية طبعا أول حاجة. مرحبا بالجميع مرة أخرى مع أمب في إيفنت جديد استكمالا لهدفها في توفير كل مصادر الإفادة للطلاب ومن مصدر موثوق بالفعل. النهارده مع ويبينار جديد هنتكلم فيه عن التآكل في مجالات مختلفة، واللي هنبدأ بأول مجالين فيهم وهما مجال الإنشاءات والبحرية، وهيكون معانا فيهم مهندس عاصم صلاح ومهندس ألكسندر إيفانوف. ويلكم مستر عاصم، ويلكم مستر إيفانوف. We are happy to have
Welcome,
you
Mustafa.
with us today. And we hope that we will benefit the most from you and Mr. Asim, Mr. Alex and Mr. Asim. You can start now.
Thank you, Alex.
Thank
Okay, let's start and go deep in our presentation. First of all, our topics today, we will talk about five topics: introduction, corrosion causes, corrosion protection, corrosion monitoring, and the practical case studies from marine by Mr. Alex. Okay, first question: why are we using coating for steel elements? Coating for steel elements are used for three main reasons. First reason is to prevent structural properties for these steel elements. You have to keep the some properties like section area, like inertia, and if you don't coat or protect your steel element, it will be disappeared, as you see in this photo. And the second purpose is for appearance needs. Maybe in some cases you have to apply some colors for identification of piping and something like that, so that you have to coat your steel pipes. And the third reason is to reduce maintenance cost. If you don't protect your steel member, it would be very costly to be maintained every year. And I want now to hear from Mr. Alex. If he have any adding for this? Why are we coating steel members and steel elements?
Okay, you started from saying why we use coatings, yes, why we use paint and varnishes.
Exactly.
I think for today, for the current moment, coatings are the cheapest way of protection steel structures from corrosion. I mean, at the moment, we don't have a magic stick that, okay, zhuk, 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 and the metal is protected. Because as we go on our discussion, you will get to know that there are another ways of metal protection but the coatings. But the coatings at the moment are the cheapest and the more convenient for usage. I mean, you take a drum of paint, you prepare the steel, and you apply these coatings. And I mean, this is easy, and it was invented hundreds of or maybe 1,000 years ago, like a universal way of protecting different types of structures and different types of materials. Yes, and I mean, but before the application of coatings, you have to do a lot of preparation work. So you can ask him go on. We are talking about this, and we can get back to talk about this in details.
Okay. And the second question here now is what's corrosion? Well, firstly, what is corrosion, and what accelerates corrosion?
Yeah, maybe
corrosion is
okay.
a reaction.
Yes, because this is a big topic. Yes. First
Okay.
question: why we are trying to prevent from corrosion? Yes. Why we cannot leave a metal structure like this? Yes, we just we took a metal from the a plant that produces metal, somehow fabricated it, mounted it, and why we do not leave it like this? Yes, this is the question. I mean, because you know the metal is subject to corrosion. Yes, and if we
Yes.
not protected. So we most likely first lose
We
this
will lose
structure.
it. We will lose it after
Yes. It means
a
we
bit
will lose
a
this
bit of time.
productivity. We will lose money, first of all, money, yes. We will,
Yes.
it may harm people's health or the workers that
Collapse. If
operate
you
this.
are talking about bridge, it will be collapsed if you lose the properties of the element.
Yeah, yes, that's
And
why, I mean,
in the marine field, I think if you cannot protect your ship or the vessel body, you may lose the whole of the ship, right?
Right, yes, the hull. And first of all, okay, how, if you lose the ship, it's one thing, but if you lose the lives of crew, I mean, people that operate this ship, it will be more tragical for everybody. And so, I mean, of course, the owners of this metal structure, anyway, I mean, let's say a shape or any refinery plant, they, of course, they don't want investing in protection, but they don't have any other way to do this. So that's why they study how to do it more effectively, how to be on the edge of the latest technologies, how to deploy these technologies to protect their property, metallic property. Yes, first of all. Okay.
Thank you. Okay, now we are asking about what is the corrosion. The corrosion is a reaction between material and surround environment, not necessarily steel. We are talking about steel because steel is the most common material which have been used upon history. But corrosion, in general, corrosion is a reaction between a material and the surrounding environment. And we have a triangle of corrosion. If these three angles of the triangle is here, you have to protect your material from corrosion. These three angles of the triangle is cathode and anode and the electrolyte. The cathode is the positive part of the cell, and the anode is the negative part of the cell. The electrolyte is the material which we have the cathode and the anode is put in it, and we have also the electrical connection. If we have those four elements, you have an electrical cell. And now I think we have a small video explain us what is the anode and what is the cathode and how the corrosion is applied. We have four components to be represented for corrosion. We have the anode, the negative part. In this case, is the magnesium, and the metallic path, which connected the two metals. The cathode, which is the positive part of the cell, and the electrolyte, the media, which contain all of this. And this electrolyte contains positive and negatively charged ions. It's like some signs here. If you connect the anode with the cathode by the electrolyte and the metallic path between them, the anode in this case will be corroded because the electrons will pass from the anode to the cathode in the electrical connection, and you have here two cases. One metal will be corroded and one metal will be expanded. Okay, this is the chemical of corrosion. Okay, how can we protect metals from corrosion? we have here 3 topics. We will talk about metallic protection and barrier protection and application techniques. Okay, firstly, we will talk about metallic paints, or aka sacrificial paints. These paints, its idea belongs to that you have to coat the steel surface with a low noble metal like zinc, and if you have any scratches in the metal surface, the zinc in this case will be corroded, not the steel metal, not the base metal. The sacrificial layer will be corroded, and that will protect your element. And we have now a small video which explains the idea. Here you have 2 samples. One sample is steel anchor which connected to a zinc plate, and in the other hand we have steel anchor only, or steel bolt only. And here in this experiment, you will add some HCl, or very strong acid, which will corrode, used to corrode the steel metal. And as you can see, you have here in the right hand, you have reaction between the bolt and the acid, and in the left hand, the steel bolt is still there, and the zinc sacrificed itself to protect the steel. And now you will cut the link between zinc and the steel bolt. And as you can see, after cutting the link between zinc and steel bolt will be corroded also, and will be chemically reacted. And this experiment show you what is the idea of sacrificial paints. And I want to hear from Mr. Alex.
Yes, this method is widely used in marine field. Maybe you heard about sacrificial anodes.
Yes.
This is sort of like
cathodic protection.
Bars. Yes, metal bars, 5 or 10 kilograms. It depends on the size of the vessel or the size of the ship. Made of zinc or aluminum. It depends. So zinc or aluminum are like the metal that will sacrifice itself, while the rest of the hull of the ship, for example, will stay protected. I mean, you just weld this metal, this aluminum or zinc plates to the hull of the vessel, to the underwater part, because you need electrolyte, electrolyte that will make this environment. The
electrolyte here in our case is the seawater, or surrounding water.
Yes. Yeah, so you weld to the hull, and for example, the service life of this bars, let's say 2-3 years. So it's just between the laying up the vessel into the dry dock. I mean, when you get the vessel up, you see that
go to maintenance.
Yes, between maintenances, yes, between the cycles of maintenance, these aluminum or zinc plates, they just decreases in size, gets lower, and sacrifice themselves to protect the metal hull of the ship. But it works along with the coatings itself. It doesn't contribute much. I mean, it contributes, but just a small part for the protection, while the main part of the protection of the metal hull of a ship are coatings. Is coating, yeah.
So to summarize what you have told us now, that in the vessels we have two line of defense. First line is the protection painting for the ship or the vessel body, and the other line of defense is the zinc plates, which called cathodic protection, right?
Yes, you are quite right. So, I mean, double protection, I would say, yes. Double
Okay.
protection, yes. Well, and of course, zinc-based coatings also exist. You know about this. I mean, it's like not the galvanizing, but the so-called cold zinc application when you apply first layer of materials that contain zinc itself.
Zinc. Yeah,
In,
like zinc-rich primer.
Yes, like primers containing zinc to, how to say, to sacrifice. I mean, it's just small particles of zinc inside of the solution of a paint material.
Okay, thank you. And now we have another video which show us how the by the way sacrificial painting, the most common sacrificial painting in the market is the galvanized steel. The galvanized steel is to apply a layer of zinc outside the steel elements, as Mr. Alex said, to make to act as a sacrificial element for the main board. And now here we have the hot deep galvanization process. You are putting the steel elements, the bare steel elements, in like a boiled in a boiled zinc things, and after that you bring up the elements and like make a finishing works for it, and the final product is a steel element which have been coated by a zinc layer, which will work as a sacrificial layer. Okay. The second option in protecting steel by paints is the barrier paints. The idea of barrier paints. Okay.
Excuse me, Asim. Let's just talk about this galvanizing method a little bit deeper. Of course, it's a good way of protection. Absolutely. I mean, effective. But at the same time, first of all, keep in mind that you are limited with the dimensions of this bath, galvanizing bath. So big details, big structures are not subject to use this sort of
protection.
Yes. Yeah, because only maybe small pipes or small, I don't know, bars or
lighting bulbs, I think. Lighting bulbs, and even small structures. Even in Egypt, you don't have many companies which use this technology. And as you say, that it's a very good point. The galvanization is limiting you with the dimension of the hot dip galvanizing sink.
But
right?
Yeah, because
if you want to, you cannot use this technology for ship industry or vessel construction.
Yes, only for small, how to say, most important parts. For example, like handrails, or which are exposed to atmospheric, how to say, atmospheric environment, and what else? Because and to have it costs a lot. I mean, to keep such a bath at your yard if you don't have enough work to do. I mean, so not every yard in any country has such a facility to use galvanizing.
So we are using this facility or this technology only for bulbs, for lighting bulbs, for small structures which can be put inside the hot dip galvanizing thing, but it's not so common in the ship or marine industry.
Yes. Yeah.
Thank
And
you for this.
by the way, you have to have, I mean, special coatings that are compatible, that can be applied over this zinc layer. I mean, there are only a special line of coatings. Not every coating can be applied over zinc. I mean, to adhere well. So only a few types of coatings are suitable for this process.
Okay, but I think in the other hand, you have some pros for this technology. In my opinion, in some members like the lighting bulb, like the small piping, this technology enable you to like coat inside the pipe, and this part
Yes, right.
inside the pipe is so difficult to apply painting for it, despite if you can use this technology. I think this technology, the biggest advantage for it is you can reach very narrow and very difficult areas in the part itself.
You're quite right, Asim. Yes, because it penetrates everywhere, while while in most times of the for the pipes with small the diameter, it's impossible to reach with any other type of
Exactly.
preparation.
Exactly.
Right.
You want to say that the galvanization process is have some areas in which you are mandatory to use it, and you cannot use it in some areas when you have a bigger bars like the ship or the vessel
Yeah,
bodies.
big metal
Okay, I
structures,
agree
we'll
with
say.
you.
Yes, I think not only in the ship industry, but as well any construction of
Even in
huge
the
modules.
construction, even sometimes you have truss members or bridges which have dimensions, very big dimensions. You cannot apply this process on it, and you have to choose another protection way.
Yes, you're quite right. Absolutely.
Okay, thank you.
Thank
Thank you,
you.
Mr. Alk. The other type of painting is the barrier paints. The barrier paints have another like idea to protect the steel metal. It's about you are preventing if you can remember the three parts of corrosion cell. You have cathode, and you have anode, and you have electrolyte. In this idea, you have to cut this link. You have to separate the electrolyte out from the cathode and the anode. You prevent the oxygen, the water, the salt from reaching the bare steel. And as you can see in this picture, on the right hand you have the bare steel after blasting. This is the color of steel right after blasting, and the other hand, in the left hand, you can see the first coat after applying. And now we have a video during the application of this barrier coat. Okay. Do you have any?
Yeah, I mean, talking about the barrier, it's just what we have started from. So, I mean, most of the painting system, coating system, they provide this barrier. So we get rid of the water and leaving steel protected by covering with the thin film of coating, yes, on it.
Okay. And by the way, this is from our recent project with Mr. Alex.
Yeah,
This ship.
yes. Yeah, talking about this recent project in Egypt, in Aswan, which is located in one of
Yes.
the driest city of the world. Yes, we must mention that there's almost no electrolyte, and I spent there, for example, a week, and I saw a lot of bare steel absolutely uncoated,
Yes.
expose it to to sun, and it had no visible corrosion at all. I mean,
No,
I was
but
amazed.
it will be corroded. Maybe it takes more time than
Yes,
places here even in Egypt like Alexandria or Cairo. Aswan is more have more dry weather, but bare steel will corrode everywhere.
yeah,
Maybe
absolutely.
take sometimes.
I
Okay.
mean, same country, Egypt, yes,
Yeah.
and you will have two
Yes.
absolutely different environments in Cairo, which is at the seaside, and at Nile, in Aswan, you have absolutely
Yes.
different uh, ways of how the corrosion will take place. Yeah, so
Okay.
I
Okay,
mean,
not to confuse the audience, but Mr. Alex means that if you can see in the right hand, you can see the bare steel. I think in some places here, even in Egypt, like Alexandria or Cairo or Suez, you cannot let this bare steel exposed to the surface more than I think 6 hours, 5 hours, and after that it will be go reddish. But
mhm,
in some other places like Aswan, the place for this project, you can let the bare steel exposed to the weather, I think for 1 day, 2 days, and it will not go to the reddish appearance. And that's
absolutely, yes,
because of the ambient. That's because of the ambient condition and the surrounding temperature and surrounding humidity, right?
absolutely right. I do agree
Okay.
with you.
And now we are talking about application technique. We saw in the previous video the application of barrier paints. But before that, we all need to know about what is the surface preparation. I think surface preparation is the most important process in painting industry. You agree with me? I think.
Yes, I mean it's the most cost consuming, and how to say, how you do the surface preparation, it will depend what the result you will achieve. I mean the
Yes.
result
If
the
you
result 100% depends on the surface preparation you make before the application. So
okay, if you apply right surface preparation and use low cost paint is more effective than you don't apply surface preparation and use a high cost painting. You are right. You are agree with me, I think.
absolutely, I mean, yes, one goes after another, and each part of this process is important. More, so you can't say, okay, I will do good preparation, but will save some money on paintings. So everything in this chain
It's important,
is
but
as
I
important
mean
as it is.
I meant I meant here that surface preparation is the most important phase in the painting industry. My question is, if you are choosing between two things, you apply right surface preparation and good surface preparation, but use low cost painting. And the other choice is to not to apply any surface preparation, but use a high cost paint. What would you choose between these two choices?
I mean, of course, if I have a possibility to do good surface preparation, proper surface preparation, and the coatings themselves, I mean, the price of coatings or uh, the brand of the material you use is not as important. While if
Yes.
you do not do any preparation at all, the best coating will not save your will not protect your metal structure in a proper way.
Exactly, I agree with you. And the question here is, why shall we treat the surface? I think that we shall treat the surface for these 4 reasons. First reason is to enhance the adhesion between the coating layer and the metal. And the second reason is to remove any contamination. You may have salt, you may have dirts on the surface. You have to remove it. And the third reason is to surface smoothing. You may have some irregularity in the surface. You have to remove it before painting. And for the fourth reason is to remove the so for rust prevention. You may have some water on the surface, invisible, you cannot see it, and the surface preparation technique will remove this rust prevention. And we have 6 types of surface preparation. I think the most common is the first and second choice, but we have 6 method for surface preparation. The more common surface preparation technique is the dry abrasive blast. When you are using dry blasting, as you can see in this video from our recent project. Here, as you can see, the gray color is the bare steel, and the reddish color is the corroded surface. Okay. This is the first
Let's talk about a little bit about abrasive blasting. Yes. I mean,
yes.
I want some comments if you don't mind. At the moment, this method of preparation, I think it was invented some 50 years ago, something like this, it still remains the most effective way of getting rid of the rust on the surface. I mean, this is the quickest, I mean, the fastest, the more economical way. But of course, it has a lot of disadvantages on the other side, like it's harmful to for the health of the operator. It's harmful for the environment. It produces a lot of dust and so on. It's okay. You have some places that you are not allowed to deploy this method.
Places. Yes.
A lot of places, yes, because dust penetrates everywhere. Dust is, for example, yes, as you may see on this picture, there's a vessel over there, yes, another ship. So if an owner of this vessel says, for example, oh, I don't want to see dust on my surface, you had to choose something less dusty, for example, water jetting, hand prepare. No, they are the method that we will be talking a little bit later, yes. So, but at the moment, it's quick and the most effective.
So it's the most effective way for surface preparation, but it has some disadvantages. But if you can choose one way to prepare your surface, you will choose, unfortunately, of course, you will choose the dry abrasive method, right?
Oh, okay, yes, but for example, for the marine, yes, but for example, if we will be talking about, if we talk about automotive industry, you will not be using blasting. I mean, only for the small parts. Only
in some cases you cannot use this technique.
Sort of preparation. Absolutely right.
The second type of surface preparation, and the most common also, is the hand and power tooling. We have a video for the hand tooling.
Can we just get back to the previous picture, if you don't mind?
Okay.
Yes. Well, just we will be talking, yeah, this is the oldest and one of the most effective ways,
Right.
but there's some disadvantage before we start. It cannot remove mill scale. Yes, we will be talking about mill scale.
I agree with you. Yeah.
And on
We'll
the
talk
photo,
about this.
on the photo on the right, as you may see, yes, this
You can see mill scale here.
mill scale on this bar, on this
Here.
T bar or what it is. Yeah, it is. So I mean, maybe it just smooth the sharp edges. It's not intended to remove the mill scale, but maybe it smooths the edges of the bar itself. While this power tooling is not intended for the removing the mill scale.
So it is the oldest way, but it has some limitations when you are talking about new steel elements
New
which
steel.
have mill scale on the surface of these elements. You cannot. It will not be very effective.
Yes, right.
Here you can see the hand tooling, and this is the power tooling to remove the residuals from the surface. And the third way here we have is the wet blasting, and I think wet blasting is very common in the marine industry, or more common than any other field. And not very common, but more common. I saw wet blasting or hydroblasting, as you explained to me before, in the marine works more than any other field.
Yes, I think this type of surface preparation, it became popular because of the ecological regulations. So in Europe, yards or producers, metal, people started to search another way of preparation because they cannot just use ordinary dry blasting, and so they invented these machines that produces high pressure. It's ultra high pressure, 2,000 kilograms on 2,000 bars, which remove the paint completely. They can produce a huge energy, kinetic energy that, as you see, it's the speed of this type of water jetting is almost similar to dry blasting. I mean, it's almost the same productivity, but it is also impossible to remove the mill scale with this method. So far, this type of surface preparation is only for the steel structures that were painted before somewhere. So sometimes in the past, somebody dry blasted them and painted them. Now you can use hydroblasting to remove just previous old coatings.
Okay, as we can see in this video, it is this way of surface preparation is used to only just to remove the old coating out of the surface. Like
yeah, it doesn't produce the profile, surface profile. I mean, this necessary surface, this peaks to adhere the paint on it.
So we cannot use this method if we need to have surface profile. It's only for to remove the old paint coating layer. Okay, and we have also another way for surface preparation, which is not so common, but it's type of surface preparation which called flame cleaning. And the flame cleaning is based on the different expansion between metals. or between steel, like steel and steel oxide. When you subject the metal to this flame, as we can see now, it will remove the melt scale or the residuals on the surface of the metal. It's not so common. I didn't subject, or I didn't see this way on practically, but in some cases you can use this way. I think Mr. Ax, did you ever before see this way before?
I've seen it once, but it was not effective at all. I mean, at one yard which where the normal blasting was not allowed, they brought these machines. They spent a lot of diesel,
Oh,
and the productivity. I mean, they wanted to remove maybe 2 millimeters of old coatings, 2 or 3 millimeters, something like that. A lot, quite thick. So you can imagine, yes, 3,000.
And I think you have here some hazard in this operation, right? You have many limitation. You can, I think you have to evacuate the area from any public presence. I think it's
Yes,
very
it produces a lot of
hazard way,
noise. It
and a
produces
lot
a
of
lot of
noise. Yes.
noise. And I mean, they have started, and this coating start to burn a lot of
Yes.
black, how do they say, black
Black dust.
fumes.
Yes, or fumes. Yeah.
It was a disaster. In fact, they stopped this experiment and said, okay, we would rather use hand power tooling than this sort of method. Maybe in some, okay, some small plates like this one, which you can see on the video, for that part of work, it is quite practical, but in other cases, people just stay clear of it.
Okay, so it's not a so common way. It's only used for very narrow cases, but
Maybe, yes.
you maybe you will see this method in your career. Okay, the third way is beckling, and I think beckling is not so common in the construction nor the marine industry, but it's a way to treat the surface of steel to have coils like as you can see this way. The beckling itself, the beckling operation is depends on that you have steel coils which will be flattened, and after that it will be like submerged in an acid sink, and after that it will be washed with water, and after that it will be dried, and you will have now the steel coil out of any surface residual or any mill scale. You will have this shape of a steel surface.
Yeah, I think pickling looks quite similar to the galvanizing. Yes, the same passivation method.
Yeah, it's
Like, I mean, but maybe more complicated because you have a lot of buses, different buses, and then rinsing the metal from this acid. Yes, you must get rid of this acid, and only after you will receive. And I think only small quantity of yards, small quantity of factories may have this type of machinery to have.
It's a very complicated method, not so common here in Egypt. By the way, we only have one factory which have this technology. I think in our factory, as steel in Alexandria, Khela, we have a plant for this process, but I think this is maybe the only plant. It's not so common. It
Yeah,
have technology. It have very complicated technology, but it's a way to surface preparation.
sure.
Okay, and the sixth method is the weathering. Weathering is somehow if you have the steel members which have mill scale on its surface, the best way, if you have time, the best way to remove this mill scale, if you cannot apply dry abrasive, you have to leave it on the temperature, and temperature will do it. Temperature will remove the mill scale out from the surface, right?
Yeah, I would say it's a passive way of surface preparation. You just leave the metal like this if you have a possibility, yes, to wait. I mean, sometimes it takes 6 months. It depends on the region, as we said, yes, because
Yes.
at the sea coast it will take less time. Somewhere in the deep dry regions, it would take much more time to wait, because if you can wait, just leave the steel outside and wait while when
So,
the mill scale just fall down itself.
a passive way for surface preparation. It's a very good expression.
Yes, no money consuming.
No
Yes,
money. Yeah.
just
It's no. It's only
if you
time
have time.
consuming, but not money consuming.
Absolutely.
Okay, and now we are going to another point. How can we classify the rust? Is the rust have the same grade? The answer, I think, no. We have 4 grades for rust as per the ISO all I think all painting steel painting standards. We have four degrees for rust grade A, rust grade B, and C and D. And what is the difference between these four types of rust? In rust grade A, the surface is almost all the surface is covered with mill scale, and in rust grade B, you can see here some small bits of corrosion, and you also have areas of mill scale. And in rust grade C, you will not see any mill scale, and the surface is full of small bits. And in rust grade D, you will not see any mill scale, of course, and you can see now big bits of in the steel, and you can face some thickness decreasing in thickness because of the rust, right?
Yes, it's just they differ from one another, just the how long they stayed exposed to
To the ambient
ambient
conditions,
environment.
yes.
Yeah, so I mean, it's rest A, it's most likely new metal, just came from a plant, metal plant, whatever. Rest B, it's just stayed a little bit outside. Rest C, I mean, maybe rest D took maybe several years to achieve such a grade. I mean, for rust D, I don't know, maybe 10 years, 5 years. It depends in what kind of environment it was.
But in some cases we are facing we have to deal with members which are subjected to rust grade D. Maybe in some cases you have all the stored members, all the stored steel plates which have been subjected to rust grade D, and we have to deal with it. It will not be like scrapped. You have to use it, and you have to protect it by painting or by any other way, right?
Yes, I mean, in your daily working life, you deal with all sorts of uh, rust. I mean, also all types of A, B, C, D, or all of them, yes, are present on a daily basis.
Okay. And how can we measure the quality of surface treatment? We now have two topics. We introduce the audience to the type of rust, and we introduce the audience to the types of surface treatment. And now we have to make a mix between these two topics. Now we know about the dry abrasive and the hand and power tooling technique. These two techniques is the most common techniques. And now we want to know how can we describe the surface of every type of surface preparation. And to cut it short, in hand and power tooling, we have two grades of surface preparation, the ST2 and the ST3. The ST2 when you use the hand tool cleaning, and the ST3 when you have to use the power tool cleaning. And on the other hand, for dry abrasive, we have four grades for surface preparation: SA1, SA2, SA2.5, and SA3. And now we will show you how we can differ between them. In this table, you have columns and rows. In the column, you can see the cleaning degree, ST2 and ST3. And on the rows, you can see the C grade, the rust grade A, B, C, D. And as you can see, in rust grade A, which have almost all the surface covered by mill scale, you can, if you go to ST2 or ST3, you cannot not applicable. You cannot apply ST2 or ST3 for grade A. You cannot remove, as Mr. Alex said before, you cannot remove mill scale from surface easily. It needs more power and more powerful tool to remove it. And in this case, you cannot remove mill scale for rust grade A using the power nor the hand tooling, right?
Yes, absolutely. I mean, for now we're talking about the quality control, yes, a little bit, because this is all these are visual, yes, visual standards, and we may decide when we see a metal structure with the rust what type of preparation should we choose, yes, whether it's enough to use hand tooling, or should we deploy dry abrasive blasting. It depends which grade of steel we have, which grade of steel is in front of us. So yeah, sure, if it's possible to use ST2 or ST3 on the old weathered steel with like grade C or D, it's better to use this, yes. But if there is middle scale, you must absolutely use dry abrasive blasting.
Okay, and on the other hand, if we are talking about the dry abrasive tool, we have four degrees: SA1, SA2, SA2.5, and SA3. And also in the row side, we have rust grade A, B, C, D. And as Mr. Alex explained before, as you can see, we cannot apply nor SA1 nor SA2 in the rust grade A. So I think that it may be more economical, or may be more cost-wise. If you are looking for cost-wise elements or members with rust grade A, is a sort of not preferable to use if you cannot apply dry abrasive, I think, right?
I mean, yes, SA1, yes, it's just a standard, yes. It's how to
Yes.
say, not thorough, a quick type of abrasive blasting, yes, it's called. So if you just trying to get rid of, remove the mill scale with just doing a quick abrasive blast, you will not achieve a good result. The result you want, you will not remove it with SA1 or SA2. I mean, you need something more thorough, like SA2.5, only this standard. I mean, you just need to operator of a blaster operator. He must, or they must wait a little bit and produce a thorough surface preparation to remove to the surface, like you see on the photo. This photo in front of the SA2. Yes, you will, while you achieve this sort of visual standard, that you must make sure that you have removed all the mill scale before the application of any paint product. I mean, because we didn't tell about this. Maybe we must get back a little bit and say that removing the mill scale in our industry is very important, is very critical, because mill scale, as you saw at the photos about the weathering, mill scales, it falls down with the time, and if you just apply any paint on mill scale, it will fall down with mill scale throughout the time. I mean, in 3-5 months, it will just fall down with the paint. So if you didn't remove it, you would not receive a good result. You will have corrosion at a very short term.
So you want to say that removing mill scale is a very important process before applying any coat. So
Yeah,
that
absolutely
so
right.
that if you have time and you need to deal with members which have rust grade A, if you have time, it will be better to wait until the rust went from grade A to grade B, then you apply a weak surface preparation on it.
Yes, right.
Okay, and now we are going to the other part is with the coating methods. Well, we have 3 coating methods. We have airless spray, and we have painting a brush, and we have roller. For airless spray, as we can see, and as we saw in a previous video, you are using a sort of equipment to apply the painting material above the surface. And for the other type, which is the painting brush, you are using like brush to apply the painting to the surface. And the third method for painting application is the roller. And as you can see in this photo, you use a painting roller to apply the coating above the surface. And now we are going to the corrosion monitoring or tests, inspection tools for painting and the surfaces. Now we will talk about the most common tests for the steel painting. Firstly, we have salt contamination test, and this is a small video. This test is used to measure the contamination of salts on the surface. As we can see here, we are like applying the surface to water, like washing the surface with water, but we use this water after that to measure the salt contamination in the water. And of course, now we are knowing about what is the salt on the surface. I think you have some adding here, Mr. Alex.
Yeah, I mean, removing the salt from the surface is a very important thing also in the industry, because salt it impacts the adhesion. First of all, I mean, it how it's called, hydroscopic thing. It attracts salt from the ambient.
And also you are not, if you apply coating upon the surface which contains salt, now you are not breaking the triangle of corrosion. Now you are just covering the surface with cathode, anode, and electrolyte. If you want to remove the electrolyte from the equation, you have to remove the salt from the surface, right?
Yes, right. I mean, yeah, it's this is called osmosis. Yeah, this when the salt attracts salt from the seawater. I mean, the if you have the salts on the surface of, for example, of metal structure which is underwater in a ballast tank or the hull of the ship, it will attract the salts which is in seawater. The water will penetrate through the barrier of the film scene, and it will make like a bubble which is subject to blow and destroy the barrier protection of film coating.
So that salt contamination test is one of the most important tests you have to apply to your protected surface, so that before after this test is used to apply after the surface preparation and before the coating itself.
Yeah,
and
so
the
it's very
second,
important to keep in mind, you must, for example, if you blasted a surface, you must start this test. It's called Bresley test or salt contamination test, and if the level of salts is above as specified, it's sometimes it's, I mean, quite often it's 50 milligrams per centimeter. You must again rewash the blasted surface.
okay.
Okay, go on.
The other test, which is so common in the industry of steel protection, is the wet film thickness, or as known, also known as the WFT. It's like a type of instrument. As you can see, it applies to the wet coating before it goes to its dry phase. And upon your measurements, you can now see how the thickness of wet coating is. And I think from the thickness of wet coating, you can like predict what will be the thickness of dry film, right?
Yeah, this method is mostly used by painters, paint applicators. I mean, the painter, it's himself, he's obliged to use this wet film gauge to control himself if he consumes enough or he doesn't overconsume.
Or he have to apply another layer.
Yeah, absolutely. So this is more for painters,
not for inspectors, not for inspectors, only for painters.
Can check the,
yes,
to make sure that
it's a very good comment. Very good comment. Yes, I didn't ever see inspectors who use this comb gauge, but as you say, yes, this method is used by the applicator himself to control himself. And the most common and the most famous way to measure the coat is the dry film thickness, or DFT. I think all people who works in the steel industry or some fields related saw this test before, and this is a small video showing you how it works. This probe is measuring the distance between the probe and the bare steel. In this picture, it's 244 microns. Okay, right. Do you have any comment on this? Okay.
Yes, it's quite common to see this.
Okay. The other way to test is crosshatch test. The crosshatch test is a test which used to give you an indication about the adhesion between the coating layer and the steel surface. You scratch the surface with this instrument, and after that put the tape and pressure on it, and after that pull the tape, and from pulling the tape you can now observe what is the surface is. If you have some scratches only, it's okay, the cohesion and adhesion between layers is good. But if you have some sort of these empty squares, you may have to back to your painting system and its adhesion with the surface.
Yeah, you described very well. Absolutely agree with you. Yes.
Okay, and now we will talk about some practical case. And by the way, these 4 pictures is from our project with Mr. Alex.
Yes, our common project.
In Aswan, our common project. It was my pleasure to meet you there, by the way. And now AMPP Egypt student chapter is benefit from your existence in Egypt in that time.
Thank you very much.
And now we have some practical cases. Mr. Alex will give comments on it.
Yes, I mean, I have chosen a couple of photos, yes, just to illustrate. Now you can see a rusty spots in ballast tank. Ballast tanks of a vessel is it's very, how to say, important area of a ship, and the ship operators or ship owners must keep this area in good condition all the time. And we can see that the ballast tanks were coated 10 years ago, maybe during the construction of a vessel, and it was coated, most likely it was 2 layers of paint, 300 or 200 microns, minimum 250 microns. And after 10 years, I observed this vessel and mentioned that, okay, the level of corrosion was something like 10 or 20% of corroded spots. These photos just demonstrate the worst places. And ship owner of this vessel decided to make just water jetting, small water jetting, not water blasting, I would say water jetting, 500 kilograms.
Not blasting because you didn't have surface profile. So that you are not willing to call it wet blasting. It's only wet. Sorry, you called it wet. Wet.
No, because we will see it high pressure washing, we would say. It's 500 kilograms.
Washing, yes. Yes.
It will not remove the rust itself, but only remove the loosened paint, the paint which is badly adhered, and then repaint it with 2 coats. It's not very effective because next photos, if you slide, Asim, please slide next photos.
Okay.
You can see, yes, this method was applied. After 2 years, they do the same thing. They just washed the ballast tanks, removed badly adhered paint with spatula, just with hand tooling, and applied. And after 2 years, you can see also the propagation of the corrosion here. So
Yeah.
we can say that this method is not as effective as it could be in comparison with dry blasting, but anyway, it gives protection for a couple of years. Yes, just for a couple of years, but sooner or later, the corrosion will, how to say, reactivate itself, and maybe in next 2 years we will see the same bad condition as we had seen before. So far, you mean the proper choice of the method of steel treatment before the application is very crucial, very important. Okay.
Okay, and the other photo is for like some spot rust, right?
Yes. Ship owner asked me why does he have a spot rust on the deck, and I found out that this type of corrosion is so-called low film thickness corrosion. So low film thickness means that during the paint application they didn't apply all coats, or maybe they just painter was very quick and applied very quickly, didn't have a thick layer. So
you have non-uniform coating thickness for all the surface.
Right, and you can see 50 microns instead of 300. So
yes.
most likely
and as I noted in the picture, we have 500 dry film thickness in other areas, right?
Maybe yes, 500 is, but here is only 54. Yes, as you can see, 54.4. So
yes.
it's
54. I saw it 544.
no, it's 54.4. Yeah, maybe not seen. It's 50 here instead of 300 so far. That's why the corrosion appeared.
Will be propagate.
Yeah, sure.
Okay.
Okay.
The other photo is for corroded handrail.
Yes, that shows that people didn't do good stripe coat. I mean, they maybe applied first with airless spray, but they have to come back and take a brush or roller. Brush is more effective in this way, and yes, and cover all this welding and places of welding
because the airless spray not propagate the painting inside the bore holes or some defects in the welding.
Yeah, I mean, yes, in this case airless spray is not as effective because you cannot apply on a small area airless spray. You need to take a brush or roller to continue with the small details of small items of handrails here.
Okay, and the other photo is about as you say, the strap coating.
Yes, stripe coating is also very important, especially when you have a, how to say, a structure with a lot of angles, holes, bars, additional bars. We must make sure that all these areas are properly painted. Make sure that there is enough film thickness to protect the entire structure, to protect the integrity of the structure.
Okay, and the other photo is about, I think, like spot rust also,
Yes, this
because of
may
not
be
strap coating.
most likely there's no stripe coat, and most likely welding seams were painted over the dust or something like this, because as we can see, the paint start to detach, start to corrode quicker than the other area of the deck that we may observe. For example, second welding seam, which is above, you can see it's quite good, on the bigger photo. Yeah, you can see a small welding seam is in a good shape, while the seam which joins the deck and the metal structure is almost completely corroded. Yes, as you can see.
Okay, and the other photo is about hydroblasting.
Yes, hydroblasting, as we were talking about, the method of preparation is quite used in the area when you cannot apply dry blasting. For example, this vessel was staying in a port, and dry blasting was not allowed there, because a lot of vessels were doing loading and loading, so nobody would
And you
let
have
them.
only to remove the painting layer, right? You only
Yeah,
want to remove the painting layer.
yeah, it removes the painting layer, and you can see the flash rust, so-called flash rust. The um, rust that appears just after the removal of the painting, which is exposed to water. Yes, it's exposed to water. Of course, it has a thin film of rust on it, and but most of the contemporary paint system, they can deal with this flash rust, and they can be applied over flash rust without any consequent problems. I mean, you can apply it and forget about this. It's not a problem today. Flash rust.
Okay, and this
As
is
this is same. We can see the application of this deck inside of the cargo hold. The painter applied it. He washed the deck and then apply just over this flash rust.
okay, and the other is about power tooling ST2.
Yes, ST2. As you can see, the result of the ST2 for the old exposed steel, old steel that have grade D, yes, C or D, most likely it was grade D. And when you use hand tooling, you will achieve such a surface. Of course, it's not as beautiful as it would be if we applied dry blasting. It is not gray, it's not, it
But
doesn't have
I think in
metallic.
this confined space like this, you cannot apply the dry blasting.
No, you
You have
can,
to
you
go
can,
to
you
and
can.
here you may see zinc or aluminum are not tab. I think it's the white part which I have
No, it just
showed
taped
it
to
in
protect.
the red.
It's just
Yes, it's
it's just taped to protect from a painting. You shouldn't paint over the surface of aluminum or zinc surface. And So far, it's a ballast tank, and as you can see, this sacrificial nodes are widely used. And in ballast tanks, you know that
inside the ballast tank,
yeah, it's
for the
immersed
audience,
in water.
the
And that's
ballast
why,
tank for who didn't very common with the marine is the part of the ship under the water. It's like a tank inside the ship. These tanks is filled with water just to keep the vessel balanced in the water,
yes,
right?
absolutely right. For balancing, to
So
change its depth and to make
so
it
that it's applied to a wet and dry cycles. Sometimes it's filled with water, sometimes it's partially filled, sometimes it's empty from water. So that I think its condition is very aggressive condition
yeah,
for
absolutely right.
corrosion.
Absolutely
Right.
right.
Okay. Okay, and now we come to end, unfortunately, and here I want to raise this point that why are the protection painting is so important, because as per the NACE and the AMPP organizations, the loss due to corrosion annually is equal to $2.5 trillion every year. And so that corrosion protection is very important process. And I think that's it. Thank you very much, Mr. Alex.
Thank
And
you, Mr. Yasser.
Mustafa, thank you, my friend. Now if any one of the audience have any questions for me or Mr. Alex, please raise your hand or come to the stage.
We have only 5 minutes, so we can take 2 or 3 questions only.
Okay.
لو سمحتوا الشباب، أي حد محتاج يسأل سؤال اعمل رايز هاند.
If you want to ask in Arabic, and we can translate to Mr. Alex, no problem.
أي حد عنده أي سؤال ممكن يرفع إيده وأفتح له المايك. باشمهندس علي سعد.
I want to ask about the self-exploration of steel and aluminium. It's different from steel, carbon steel.
Sorry, your voice is not so clear for me.
I'm asking about surface preparation of aluminium substrate.
You asking about surface preparation for aluminium surface, right?
Yeah.
Okay.
What is the recommended?
What is the recommendation if you want to apply surface preparation for aluminium? I can answer, and I think that Mr. Alex will add to me. Aluminium itself as a metal, when it's subjected to the ambient surface, the ambient condition, I'm sorry, it like consists a layer of passive layer of aluminium oxide, so that it's like a self-protected material, so that you are not in aluminium specifically, you will not need any surface protection, because the aluminium is a self protected metal. This is from my knowledge, and of course Mr. Alex can add some.
Yes, sure. This aluminum oxide acts like self-protection, but in marine sphere, we very often paint the aluminum parts of a vessel. So we don't do anything with aluminum, just clean it from the dust. and then apply special primers that are suitable for the aluminum, and that's all. For example, you want to be everything in one color, like corporation colors.
If you may apply coating for the aluminum, but only for the appearance. If you want to give color for the aluminum, not for protection.
Yeah,
right?
Yes, it protects itself. Yes, or it's a noble metal, and it protects itself as well with aluminum oxide. But yes, you paint it just for aesthetic. I would say aesthetic point of view.
Okay. Okay. If we have any other questions, Mustafa.
هل في حد عنده أسئلة تانية يا شباب؟ غالبا كده مفيش أسئلة تاني، بس لو في حد بعت لي على الواتس ولا حاجة أنا ممكن أبعت لحضرتك على الجروب يعني.
Okay. Thank you very much, my friend Alex, for being here with us, and thank you for sharing your knowledge with us. Me myself, I have some new information for me from this discussion. It was a very fruitful discussion for me, and thanks for Mustafa for giving us this stage to talk and to share knowledge.
Thank you, Mustafa. Thank you, Asif, for inviting me. Thank you, everybody who were present. Hope you managed